Alright, so we have a car traveling in a straight line along a horizontal road with speed v. The driver pushes the brake pedal, and the maximum braking force is applied. The car travels a distance d and coming to rest. The car had been traveling at twice the speed 2v. We want to compare those distances. So let's just do a before and an after. Before, v squared equals u squared plus 2a times s. And in this problem, that's v squared is going to be, you know what, we should be really clear on this. I want to be super strict here. So we're going to have a negative acceleration that we solve for. Okay, so we end up with a speed of 0 starting from an initial speed of v squared plus 2 times a times the distance we travel through. And so we're going to actually end up getting that a is negative v squared over 2d. Now we want to figure out what's happening if we're traveling at twice the speed. So let's do a little bit of math. After 0 squared is this v that's given squared. I'm going to write it with this fancy thing to let you know that it's this weird v, italics, plus 2 times a times. Now we're traveling twice the distance. Let's be clear. 0 squared equals, you know what, let's be really clear on this after. After we wind up with a speed of 0, having started at twice the speed, plus 2 times the acceleration times the new distance that we're solving for. And to be clear, this acceleration is going to be negative v squared over 2d, which we got right here. So we're going to get negative 4v squared equals 2 times negative v squared over 2d. And that's going to be d new. Let's cancel what we can. So here we're going to get, and this is negative here. Now, this will cancel out. This will cancel out. This is positive and positive, so we're going to end up getting d new is actually 4 times the original d when we go ahead and simplify. A ball is swinging in a horizontal circle is shown. Now, we don't want to know the net force. We want to know the forces that are acting. Do not draw an extra force. Rather, we have the tension and we have the weight, and it's up to these two forces to cancel, and the result of T and W is this. And that's how we're getting choice C as our answer. 73. Newton's third law, once again, the weight of the bird going down is the reaction, the Newton's third law pair can't be a downward force. If W is downward, we need an upward force on the earth from the bird. A ball is thrown vertically upwards in the air at the highest point. Its acceleration is downwards. We've done that one. All right. A varying force acts upon an object, and we want the impulse. Remember, the impulse is the area under the F versus T graph. So that's going to be 1/2 times 10 times 0.1, and that's going to give us, times 0.2. And that's going to give us 1 Newton second worth of force. And then for number 76, a car accelerates uniformly from rest. These comparison problems, again, a before and an after. If you notice, whenever we accelerate over distance, I keep going to the same formula, which is v squared equals u squared plus 2as, but let's use their variables. So v squared is 0 plus 2a times d. Let's just go ahead and get the acceleration. So v squared over 2d is the acceleration. Afterwards, v nu squared is u squared plus 2a times 2d. And we compare. V nu squared equals 0 squared plus 2. And for a, I'm going to put v squared over d times 2d. So we get some cancellation. So what we end up getting is that v nu ends up being here. Oh, this is v squared over 2d is a. So we end up, sorry, for the a I need to put v squared over 2d. So we have an extra 2 canceling here. So we get v nu, in fact, is radical 2 times v, which is choice B. 77. We slide from a smooth slope onto a rough horizontal surface where we come to rest. So all this PE here is becoming kinetic energy here, and then finally it becomes thermal energy right here. So potential to kinetic to thermal, choice D. Then question 78. Sig figs. All right. 3 sig figs, 2 sig figs, 2 sig figs. Don't even calculate. Now here. We have one current going this way and another current going this way, and we want to know what the displacement is after 5 seconds. So let's get it for each direction. In the x direction, that's going to be 0.6 times 5, which is 3. In the y direction, that's going to be 0.8 times 5, which is 4. So the displacement is I go from here and I go this way. So I wind up here. This is 4, this is 3. So the displacement is going to be 3 squared plus 4 squared under a square root, like Pythagoras' theorem, or distance formula. And I'm getting 5 meters, which is C. And then question 80. Velocity versus time, and we want acceleration versus time. So let's remember, acceleration is the slope. So I have a big negative slope, which is A. I have 0 slope, and then a big positive slope. So a big positive slope at the end. So that rules out choice 3. I need 0 slope somewhere, so that rules out choice D. And it needs to continuously change. It's not just an abrupt thing that changes because it levels off. That leaves us choice A. All right, that is question 71 through 80.